Hello and welcome to this UniTaster On Demand webinar, where today we're going to be exploring university courses in civil engineering. With these events, what we try and do is provide students with a really good guide when it comes to university subject choices and introduce different subjects, so you can go on to make really good university decisions. I'm delighted today to be joined by Dr. Therese Sheehan, who's joining us from the University of Bradford. Therese is a lecturer in civil engineering, structural engineering at the University of Bradford, and she's going to provide an introduction to what to expect on a civil engineering course and much more. Always conscious with these events, you've tuned in to hear from our excellent speakers, not from myself, so I'll pass things over to you, please, Therese.
Thank you, John. Hello, everybody. My name is Therese Sheehan, and as John said, I am a lecturer in structural engineering in the University of Bradford. Today, I'm going to talk to you about civil engineering as a subject and as a possible career choice. And as I'll explain in my presentation, structural engineering is actually one of the many subtopics within civil engineering. So today's presentation will have four parts. Firstly, I'm going to say why I think you should consider civil engineering as a career. And next, I will talk about what to expect if you decide to study civil engineering. I'll follow that with some application tips, and finally, a brief overview of the different types of career that you could expect within civil engineering. So why consider civil engineering? Well, the first question to address really is, what is civil engineering? Civil engineering is one of the oldest types of engineering, with the term civil being designated originally to differentiate between that and military engineering. Civil engineering is the design, construction and maintenance of both the natural and the built environment for people. And you might ask what I mean by the built environment. Built environment really refers to all the different types of structures that we see around us in the world. These could be buildings, bridges, dams, transportation infrastructure, etc. And the natural environment is obviously the environment within which those buildings and structures sit. Civil engineering is very, very broad, as you can probably tell. And it's about creating sort of new structures and new infrastructure for the environment, but it may also relate to maintaining or altering some of the existing structures as well. And we consider both the present needs, but also future needs. So looking ahead to what future generations might require. Civil engineers use various technologies and resources to create and modify these structures in harmony with the natural environment as well, in such a way as to minimize any damage inflicted upon the natural environment. One of the things I really like about civil engineering is that you can see physical examples of it all around you. So some of the greatest structures in the world, some of the really ancient ones and some of the modern ones, such as the Great Wall of China or the pyramids, or some of the very tall structures that we see in the world today. These are all a result of civil engineering. You can see the effects of it in day-to-day life as well. Many of our everyday activities, whether we're using running water, or taking public transport to get to school or to get to work. These all require civil engineering in order to function. So it's really about shaping the world and helping people in many different ways, and making sure that our lives run smoothly from one day to the next. There are many sub-disciplines within civil engineering. As I mentioned at the beginning of this talk, I myself am a structural engineer. But there are also disciplines such as construction engineering, geotechnical engineering, environmental engineering, water resources engineering, and transportation engineering. And there are probably many others as well. There will be many others in the future as different technologies are developed and the nature of what we require might change slightly. So I'm going to talk a little bit about what each of those subtopics is. So firstly, I'll talk about structural engineering. Structural engineering involves the design and analysis of different types of structures in supporting loads. These may be buildings or bridges or other types of structure. And they may be resisting everyday loads, such as the weight of people and goods, but they also may have to resist other types of load. For example, lateral loading from the wind or the load from an earthquake. So these are all included within structural engineering. The next type I'm going to discuss is construction engineering. So construction engineering is really more concerned with the process of constructing these structures and infrastructure. That could be the planning, that could be the maintenance of the structure as well. Nowadays, civil engineering projects are becoming very, very complex and increasingly digitalized, and managing the process and managing the many different stakeholders and disciplines that are involved, that was quite a big undertaking. So management of people and time and resources is becoming increasingly important, and all of this feeds into construction engineering. Geotechnical engineering is generally more concerned with what goes on under the ground, so looking at the design of foundations, for example, and the behaviour of the soil or the geology, and how that affects different civil engineering works. So some examples within geotechnical engineering could be tunnelling or the design of foundations. Environmental engineering is becoming increasingly important nowadays as well. This is really about preventing or managing the effects of pollution on the environment and also on human health. So this largely relates to how we deal with waste, such as solid waste, water or air pollution. And some subtopics within this could be sanitary engineering or urban engineering. Another very large area within civil engineering is water resources engineering. So this is examining how water is collected and distributed, and understanding the behaviour of water. So students would study subjects such as hydraulics to understand the mechanics of water, and also the behaviour of water in rivers or on the coast. Transportation engineering is another large subtopic within civil engineering. And transportation is concerned with the movement of people and the movement of goods. So it's really the design and the operation of different types of transportation infrastructure. This could be railways, it could be roads or highways. Also looking at how traffic, I guess the issues surrounding traffic engineering. So as you can see, there are many different subtopics within civil engineering. So what would you expect if you actually went to study it? Most civil engineering degree programs are quite broad and would include several of these topics, if not all of them, in some way within the degree program. Some degree programs do place a stronger emphasis on some topics than others. So for example, when you start looking for different civil engineering degree programs, you may come across titles such as civil and structural engineering or civil and environmental engineering. So these probably cover all of the topics to some degree, but maybe focus a little bit more on one particular area within civil engineering. Most students who are thinking of studying civil engineering would either undertake a bachelor degree or BEng program, or they may take a master's degree or MEng program. And within the UK, a BEng degree is typically 3 years in length if you do it full time, and a master's degree is typically 4 years in length. Alternatively, for students who already have a degree, there are postgraduate options as well, such as MSc courses or Master of Science courses. So these would typically be 1 year full time. Entry requirements for these would vary from university to university. Typically, an applicant would already have a bachelor degree or similar in civil engineering, but occasionally it is possible to go into civil engineering from other backgrounds as well, such as maths or physics. Many universities offer the option of doing an industrial placement year within the degree. So this could be a sandwich type degree. So for example, for a BEng course, if that was to become a sandwich program, then it might take 4 years in total. And that might consist of doing 2 years of the degree, taking a year out to work in industry, and then returning and completing the final year of the degree. And personally, I strongly recommend looking for industrial placement opportunities when you start to look at degree programs. Most universities that offer this option would promote it strongly. It's a brilliant opportunity to put the theory that you learn during the first few years of your degree into practice. It also sets students students up with many opportunities for future employment as well. And it also gives you a chance to try out one of the many career options that are presented to you in civil engineering. It can be quite difficult when you start to study the subject to decide which area interests you most. So taking an industrial placement year, it does give you a chance to try out a particular type of civil engineering. In addition to placement years, a lot of civil engineering students also take work placement during the summer period as well, in between years of their degree program. And this is another excellent opportunity, again, to put your skills into practice and also to explore different types of employment in civil engineering. Many different types of teaching and learning activities are used in civil engineering programs. Theoretical subjects are often taught through lectures and tutorials, but civil engineering programs also consist of a significant amount of laboratory work, field work, and also a lot of group work, which often takes place in the form of design projects. Design projects are a very important part of a civil engineering program because they simulate the type of work that you would carry out when you begin working in the industry typically. Civil engineering programs are designed to build a very broad range of skills so that when students graduate, they are sort of fit to work in the workplace and to meet many different types of challenges. There's usually a very heavy emphasis placed on group working skills and also on communication skills, report writing skills, and problem solving skills. So many different types of assessment are usually used in civil engineering degree programs alongside the many different types of teaching activity in order to equip you with these skills. As I mentioned previously, a lot of civil engineering programs would also provide industrial placement opportunities, or they may provide other ways of engaging with the industry as well through mentoring schemes. So a mentoring scheme might be when a practicing engineer meets with civil engineering students, or possibly allows them to visit their place of work so that they can see what they do. So all of these experiences are provided to enrich your experience as a student and to aid your learning. So what should you look for when you apply for a civil engineering degree, or what would help your application? And first I'm going to talk about what to look for in a university. One of the most important things I would say is to look for an accredited degree. So most civil engineering programs in the UK are accredited by the Joint Board of Moderators. The Joint Board of Moderators consists of a suite of professional institutions in civil engineering, such as the Institution of Structural Engineers, Institution of Civil Engineers, Institution of Highways and Transportation, and Institution of Highway Engineers. So the idea is if these institutions accredit a degree program, this is a stamp of their recognition that the degree program is of good quality and fit for purpose. Many engineers, 4 or 5 years after graduating, will look to becoming a chartered engineer. In order to become a chartered engineer, you need 2 things. You need to have an appropriate educational base, and you also need to have sufficient work experience to show that you've acquired certain skills and attributes. If a degree program is accredited, it means that it meets the requirement, the education requirement for becoming chartered. So finding an accredited degree program is the first step really in working towards being a chartered engineer. And you know, it is an important milestone to achieve after you graduate. Once an engineer becomes chartered, again they're recognised as being a competent professional who can be entrusted with larger responsibilities. In addition to looking for an accredited degree program, it's also worth looking at the type of facilities that a university offers. In particular, laboratory facilities As I mentioned previously, laboratory work is a really important part of a civil engineering degree, learning how to put theory into practice and developing hands-on skills. And universities have different types of laboratories. They may have special teaching laboratories that are purely designed to help with teaching certain subjects. And they may also have research laboratories, which are more concerned with, I guess, the research that's carried out by academics, but could also feed into your learning experience as an undergraduate student. So, ideally, a university should invest in both of these types of facilities. Another important thing to look for is the degree of industrial input into the civil engineering program. Industrial input is very important to ensure that the subjects that are taught in the university are up to date and are relevant to industrial practice. And there are many different ways in which industry can have input into a degree program in engineering. Typically, this might take place through guest lectures. So practicing engineers come in as part of your certain modules and deliver a lecture, or they may deliver lectures outside of the modules as a sort of extracurricular activity. They may also partake in mentoring students or organising visits to sites, and they may be involved in providing opportunities to undertake a work placement as well. So do look out for the different forms of industrial input into a degree program. Another item to consider as well is whether or not you may be interested in research. So if you look for a university that has research active staff, this is usually a good first step to take. Research active staff, tend to be working at the cutting edge of their own discipline, and this can feed into their teaching. So you're getting a lot of very specialist and up-to-date information about a particular topic. If for some reason you are thinking about a career in research or academia, engaging with research active staff is a good first step towards that as well. Most engineering degree programs involve some sort of research projects for undergraduate students, where you work under the supervision of a member of staff on a particular subtopic of interest. And this could pave the way for a career in research or academia later on, if you're interested in this. I would strongly advise you, if you're interested in studying civil engineering, to try and attend open days at any universities you're interested in. As I've already emphasized the importance of the facilities and the environment, getting to actually see and explore these facilities would help you to reach a decision about whether or not you think a university would offer you a suitable experience in civil engineering. So that's what to look for in a university. As for yourself, the most important thing I would say is think carefully about the subjects that you study. For engineering degree courses, maths is highly valued. For several programs, it's a requirement actually to take mathematics as a subject in order to be accepted on the program. So when it comes to choosing your own subjects for A levels or equivalent, do consider topics relevant to engineering, but in particular maths or maths-based subjects. So what type of careers could you expect if you were to work as a civil engineer? Well, civil engineering can broadly be divided into two main areas, actually, consultancy and contracting. So consultancy is more concerned with the design of structures and infrastructure, and this tends to be more office-based work, probably with occasional visits to a site. Contracting, on the other hand, it tends to be more site-based, so it's more about the maybe the construction process. So the two types need to work hand in hand, really, on large-scale projects. And you will get some companies that sort of both design and build. So for a lot of civil engineers, that's one of the main questions: is would they prefer something more office-based or more site-based? And again, this is why I recommend looking for placement opportunities while you're a student to try and experience a bit of both. There are other types of career as well. You could look into a career in research or academia. whether that's based in a university or a research-orientated company. But actually, there are many other career opportunities for civil engineers as well. Civil engineers graduate with a very broad range of skills and very strong problem solving and numeracy skills in particular. So they're actually highly valued and respected in other career areas as well, such as finance or teaching. So really, obtaining a degree in civil engineering opens a really, really broad range of career opportunities for you. So that's all I want to say to you today. Thank you very much for your attention, and best of luck with your career decisions and your career journey.